Yeah.
Okay, so we're doing 12.5, moving on to a little bit more involved probability. So independent events, another way they may say that is with replacement, which means the events in which the first event, events in which the first event does not affect the second event. Dependent events would be without replacement. So those are just two different ways you may hear it talked about, or you might see it. Events in which the first event does affect the second event. Okay, so for example, we're using a money bag. We have money, 2 quarters, 3 dimes, 4 nickels, and 1 penny in a bag. They want to know what is the probability of drawing out a dime and then a penny. Now notice here it says with replacement. So what that means is they're going to pull a dime out, but then when they go to draw for the second time, they're going to put the dime back in before they do the second drawing. Okay, so let me show you. Okay, so this is our money bag. Okay, so the first part says you're going to have to, hang on, I think I have it now. Okay, so the first one says what's the probability of a dime and then a penny. So the first part they're saying, well, what's the probability? Oh, it's not going to work for me.
The marker's up here. The pen's right up here.
Right here.
Right here.
Oh, thanks. Okay, so the first part they're asking is if I have a dime and I draw that dime out, what's the probability that I'm getting that dime? So how many dimes do I have altogether? So I have 3 opportunities. Out of how many coins do I have? 10 coins. So you're going to write down 3 over 10. Okay? Now, if I go back to that, the second thing they're asking me is what's the probability that then I get a penny? Well, how many pennies do I have? 1. Now, did I put that penny or the dime back in or not? What did the direction say? Was it with replacement or without? With. Okay, so that dime, I pulled it out and said, I got a dime. It was a 3 out of 10 chance. I'm putting it back into the bag. So now I want to know what are my chances of getting a penny. So it's 1 out of 10. So write that down. Now what you do to figure out what is the probability of both of those things happening, you multiply them together. Okay? So I get, what's 3 times 1? 3. What's 10 times 10? So 3 1/100ths of a chance of that occurring. Okay? Now, look at the next one. What's the probability of getting a quarter? So how many quarters do I have? 2. Out of 10. Then what's the probability of getting it? Now remember, I'm putting that quarter back in. I'm replacing it. Then what's the probability of me getting a nickel? Out of 10, because I still have 10 coins. Now I probably reduce within my problem. That would go to a 1. This is going to go to a what?
Oh.
Right? What goes into my 4 and my 10? 2 goes into 4 how many times?
2.
And 2 goes into 10 how many times?
5.
Okay, now multiply across. What's 1 times 2?
2.
What's 5 times 5?
25.
So you have a 2/25 chance or probability of that occurring, both of those events occurring. Okay? Do we get the idea? What's this one? Probability of a dime is what?
3 out of 10.
We have 3 dimes out of 10. We replace it. Then what's the probability of a nickel?
4 out of 10.
Again, I'd probably reduce here. 2 and a 5 again. What's 3 times 2?
6.
Oh, wait, could I reduce again here? My 2 and my 10, can I do that again? Yeah, so this would go to a 1 and a... Okay, so what's 3 times 1?
3.
What's 5 times 5?
5.
Okay, all right. Now, same thing, number 4, I just have 3 different situations, so I'd multiply it together 3 times. Okay, I'm not going to do it. You get the idea, right?
Yeah.
Okay, look at without replacement now. So that means on this very first one, again I have the same amount of coins, but it's saying to me, what's the probability of getting a dime? So what is my probability of getting a dime?
3 out of 10.
3 out of 10. Okay? So I draw that dime, and it is now gone. I am not replacing it. Okay? So remember, these are without replacement. It means that the first draw affects the second draw, because I'm not going to put that coin back in. Okay, so the next thing it asks me, well, then what's the probability of getting a penny? Okay, so I look at this, well, what's my probability? 1 out of 9. Okay, do you see how that changes? Okay, so it does affect. So in this case, okay, so this one, what did we say the probability of the dime was?
3 out of 10.
And then we did not replace that dime, so the penny became 1 out of 9 because there was only 9 coins there because we didn't replace the dime. Okay, I would reduce. This becomes a 1. This becomes a
3.
And I get for my answer
130.
Okay, look at number 2. Probability of a quarter is what? So how many coins do I have in the bag?
See?
Well, no, well, we're starting over. So start over again. New problem. 10. Okay, how many quarters are there?
2.
So 2 out of 10 chance. Am I putting the quarter back?
No.
No, I'm not. Therefore, how many coins do I now have in the bag?
8.
How many?
9.
9. The first draw, you had a chance of pulling 2 out. So there was 2 different dimes, but you only pulled 1 out. Okay? So my bottom number is 9, and my top number is how many nickels are in there?
4.
Okay? Reduce. What goes into 4 and 10? 2 goes into 4.
2.
2 goes into 10.
5.
Multiply across. I get what?
4.
Over.
45.
Okay? And I'm not going to do the last 2. I think you get the idea, right?
Yeah.
Yes? Okay. Tomorrow, this is what your homework's going to be on. Okay, so make sure your notes are with you tomorrow. You'll have a worksheet. You'll come in, and we'll work together on it. Okay? Thank you.